All right, so here we are now, we're doing a proportion test. So we're gonna look back at our old friend p hat. And really this is just one of those things to tell us if we're going to have, if one probability is larger than another probability. R is the number of successes, N is the number of trials, p hat is calculated the same way, q hat's the same way. Our mean, our mu is p. And our standard deviation is thus, and this should be a 5. And n times p and n times q have to be greater than 5. You have a right tail test, a left tail test, and a two tail test. And since p is a probability, the value of k must be between 0 and 1. So whenever you're testing these, k is supposed to be a value between 0 and 1. So here it's a little weird because you have p, but then you have a p-value. The p-value is what we compare to alpha. The p is our population probability or population proportion, which is something different. So please try to avoid confusing the two. Most people do a fine job keeping it straight. And then here is our formula to find our z. So the nice thing here is we're back to using a z-table again, which makes things a little bit easier to work with. One of the beautifully frustrating things that you'll notice here is it's the same 5 steps. State your null and alternate hypotheses, set your level of alpha, solve for your test statistic. Once you have your test statistic, you can solve for your p-value. Once you have your p-value, make a decision about the null, keep it or reject it, and then interpret your results in the context of the problem. So we're going through our same 5-step process that we've been going through before. So here we have a baseball team that has historical on-base percentage of 30%. So that would mean P is 0.3. P is 0.3, which would then subsequently mean that Q is 0.70. Suppose the first half of the new season of 225 at-bats, only 88 players have reached base. So N is 225, R is 0.88. Can we justify that the team is improving with a 1% level of significance? Well, let's figure that out. P hat would be 88 over 225, which is, where am I here? 0.39. All right. So we'll establish our null and alternate hypotheses. So the null hypothesis, P equals 0.30. The alternate hypothesis, P is greater than 0.30, because we want to know if they're improving. 0.39, not Q, 0.39. One thing that we do need to do, I kind of glossed over it on the other part, is we also need to test N times P and N times Q. Our alpha is 0.01. So we do need to do the NP greater than 5, NQ greater than 5 test. When you work these out, you get 60, N times P is 67.5, which is greater than 5, so that's good. And when you do N times Q, you get 157.5, which is greater than 5. So you are good to go. So don't forget to do that N times P is greater than 5 part like I almost did. So we're going to solve for our test statistic Z. So step 2, Z is going to equal 0.39 minus 0.30 over 0.30, 0.70 divided by 225. we get a z-value of 2.95. So from the table, the p-value equals 0.9984. Just to check things now, p is greater than 0.3, so we're going to have to do 1 minus 0.9984, which is going to give us 0.0016. This is the p-value we will use. So as we move into step 4, we're going to do p-value. We're going to do alpha, 0.0016, 0.01. That's in the less than or equal to category. We will reject the null. So this means for step 5, at the 1% level of significance, the team is improving, doing better. What did it say? The team is improving. Now, in the calculator, it is stat tests option 5, 1 prop z test. You do a 1 prop z test, and it'll ask you for, here I'll show you. So stat tests option 5, the 1 prop z test. It asks for p sub 0, so in our case that would be 0.30. Our x value is 88 because it uses x whereas we use r. N is 225. Is the team doing better? So they'd be greater than. We get the same or very close z value that we got before. We got a very similar p value that we got before. And everything stays the same. The reason for the different z and different p is because if you notice my p hat here, 39.111111 repeating, because this is using all those digits, that's why we're slightly off a little bit because of the rounding. At this point in the note packet, there's a couple of in-class practice examples. With these in-class practice examples, what I'm going to do is I'll make that the next video, and I'm just going to show you how to do these in the calculator, and they'll all be one video together. So